resultant. Two forces, one line. What's the overall push? 6 newtons right, 4 left. 6 minus 4 gives a 2 newton resultant. The resultant is not 0, so the box accelerates. Find the resultant. 10 newtons right, 4 left, 6 to the right, and off it goes. But 300 each way in a tug-of-war? Balanced, nothing moves. What if the resultant force is 0? Newton's first law: an object stays at rest, or keeps moving in a straight line at constant speed, unless a resultant force acts. At rest, it stays at rest. Weight and normal cancel. Already moving, it glides on at constant velocity. Does a moving object need a force to keep going? You must keep pushing to keep it moving. That's wrong. On frictionless ice, no force is needed, it just keeps going. It slows only because of friction or drag. So what does a resultant force actually change? It changes velocity, speed, or direction, or both. A ball on a string keeps the same speed, but its direction changes every instant, so there must be a force. Now put a number on it. Resultant force equals mass times acceleration. F equals ma. F is always the resultant force, not just one force on its own. F in newtons, m in kilograms, or in meters per second squared. 1 newton is 1 kilogram meter per second squared. The link A equals F over m. Same mass, double the force. Double the force means double the acceleration. So A is directly proportional to F. Same force, heavy car versus light cycle. Same force, small mass, big acceleration. So A is inversely proportional to m. Putting it together, A is proportional to F over m. The constant of proportionality is 1. So A equals F over m. Now real problems, free body diagram every time. F equals ma with free body diagrams. A 6 newton push on a 2 kilogram box. Weight and normal cancel, resultant is 6 newtons. A equals F over m, 6 over 2, 3 meters per second squared. A car, 1000 kilograms. Thrust 3000 newtons, drag 1000. Resultant is 2000 newtons. A equals 2000 over 1000, 2 meters per second squared forwards. A 12 newton resultant gives 4 meters per second squared. Find the mass. M equals F over 12 over 4, 3 kilograms. Pitfall: which force equals ma? 3 newtons, 5 newtons right and 2 newtons left. Is it F1, or F2, or F3? No. Only F net equals F1 plus F2 minus F3 equals ma. That's 6 newtons. One last trap. Are mass and weight the same thing? No. Mass is amount of matter, the same everywhere. Weight is the force of gravity, W equals mg, it changes with place. Same 60 kilograms on Earth and on the Moon, but 600 newtons versus about 100. Same mass, different weight. Why the same acceleration if drag and friction are 0? Watch a heavy mass and a light mass side by side. Their weights differ, but they fall together. Masses are not the same. Weights are not the same. But their ratio is the same. W1 over M1 equals W2 over M2 equals g. So both accelerate at the same g.